Well, here we are again, and this time we're going to actually look at different ways that we can use our mole equations to help us solve different problems. This one in particular that we're going to look at in this video is working out the percentage composition by mass. If you remember when we talked about alloys for metals and stuff, we said that we could mix different metals together and have a different amount of them. So when we did sterling silver, we added a few percentage of copper and things like that. So with this, we can use this technique to work out exactly what substances are made of and report it as a percentage. So if we have a look here, we're looking at this idea here where we can have the percentage composition of a substance, and essentially it's like putting together a pie graph to say what it's made up of, but we don't use pie graphs and we use the mole to help us find it out. So if we look at our definitions, we can see that the composition of a compound is expressed in terms of its percentage composition by mass. Okay, so we're dealing with mass in grams here. And if we look at that, it means that if we assume we have 100 grams of substance, then our percentages can become grams. If we look at these pie charts here, this first one says percentage composition of any amount of sucrose. So it doesn't matter how much there is. There could be 50 grams, there could be 1500 grams, it doesn't really matter. And 51.41% of that mass would be oxygen. 42.12% of that mass would be carbon, and 6.48% of that mass would be hydrogen. If we add it all up, it essentially comes to 100%, and we've just got this little extra bit here from rounding. But if we would assume that we had 100 grams exactly of sucrose, because these are percentages, then that means that 51.41 grams of it would be oxygen, 42.12 grams of it would be carbon, and 6.84 grams of it would be hydrogen. And remembering that anytime we have mass, we can find out a mole, you might be able to see where this is going. So if we look at the formula for percentage mass, it's just like working out what percentage you got on a test, okay? You guys are really familiar with that. You know how to do it. You've been doing it for as long as you've been at school. But essentially, if we want to find out the percentage by mass of a specific element, we take the mass of that element in 1 mole of the compound, which is going to be our molar mass from the periodic table. Okay, so if I wanted to know how much magnesium, then it would be 24.31. Okay, divided by the mass of 1 mole of the total compound. So this is the total molar mass of the compound that we're looking at. Okay, so if we were looking at something like water, H2O, okay, and we wanted to know how much hydrogen is that, okay, well, that would be the mass of hydrogen in 1 mole of the compound is going to be 2 times 1 because I've got 2 hydrogens. So that would be 2, and then I'm going to divide by the total mass of the compound of 1 mole divided by 18. Okay, and I'm going to multiply that by 100 over 1 to get my percentage. Okay, so this is what it means. It's basically saying the mark that you got out of how many marks that were available multiplied by 100 over 1. The same way you do a percentage any other way. So let's have a look at this one. It says that stannous fluoride is an active ingredient in toothpaste. Okay, and we're asked to find the percentage composition by mass of each element in the compound. Okay, so if we want to find the percentage tin, okay, that's going to be the molar mass of tin divided by the total molar mass of stannous fluoride, which is going to be 1 lot of tin and 2 lots of fluorine, okay, multiplied by 100 over 1. Okay, and then if we wanted to find fluorine, remembering that we've got 2 fluorines in each lot of our compound, we would find the percentage of fluorine is going to equal the molar mass of fluorine, and this time it's going to be times 2 because I've got 2 fluorines in it. Okay, and then that one's going to be divided by the molar mass of SnF2. again multiplied by 100 over 1, and if you add these two together, they should add to 100%. Okay, if there's only two things in it, it should add to 100%. So if we look at that, okay, because this is easier than looking it up on the periodic table and waiting for me to do the calculations, we can see that the molar mass of stannous fluoride is 118.7 plus 2 times 19. So this is the MR of tin, and then this is 2 times the MR of fluorine. So fluorine is 19 per each one. So that gives me a total of 156.7 grams per mole, remembering that molar mass have grams per mole. Okay, so 1 mole of stannous fluoride, because this is the number of grams per 1 mole, is 156.7 grams. Then the mass of tin in 1 mole of stannous fluoride, I've only got 1 tin atom, so if I had 1 mole of it, it's going to be 118.7. Okay, when I plug that into my calculation, I should get 1187 divided by 156.7 multiplied by 100 over 1, which is 75.7%, and that was tin. Okay, the percentage of tin. We go through the same process for fluorine. We take fluorine, and 1 mole of stannous fluoride is 2 times 19, because I've got 2 in each compound, and that's going to be 38 grams. So I'm going to take that mass and divide it by the total mass in 1 mole, which is 156.7, multiply by 100 over 1 to get my percentage, and I end up with 24.3%, and this is fluorine. Okay, but not to be confused with fluorine as in fluorine gas, which is F2 on its own. This is fluorine in a compound. So hopefully that seems pretty straightforward. We're going to take the percentage of work out the percentage of something in a substance by taking the mass of that thing and dividing by the total mass of the compound. Okay, so here's a question to have a look at that again. So if you're feeling pretty confident with this, have a go at this one on your own and then just fast forward through my explanation and check your answer. Okay, otherwise this video will go on for a while. So again, now we've been given the formula of the compound here, alumina, okay, which is Al2O3, and we want to know the mass of aluminium that can be extracted given a quantity of alumina. Well, if that's the case, what we want to do is work out the percentage aluminium. Okay, if we work out the percentage, we can then work out that percentage as a mass of anything and work out how much aluminium we would get. Going through the same process, first things first, work out the molar mass of our alumina, and you should get 102 grams per mole by adding up 2 lots of aluminium and 3 lots of oxygen. Then you work out aluminium. Well, we've got 2 lots of aluminium in each molecule, so we'll get 2 times the molar mass of aluminium, which is 27. So for every mole, there'll be 54 grams of aluminium. We divide that by our 102, and we work out that there's 52.9%. Now that means we can use that to work out how much aluminium we would get from any mass. So essentially, if I said, okay, I've got 1,000 grams of alumina, how much would I get? Well, I would get 530 grams of aluminium. Okay, because I'm going to take my 1,000 and multiply by 53%. Okay, and that will give me 530 grams. So that's working out the percentage of a substance in terms of its mass. Okay, so have a practice at doing a couple of those. You could work out the percentage of sodium in sodium chloride. You could work out the percentage oxygen in ethanol or anything like that. Just have a couple of goes at it, and then that's this video done. So practice that skill and then move on to the next one. Okay.